Okay, I'm going to solve a problem for quiz 2 and test 2. Okay, question number 1. So we have set of coordinates. Let's say negative 6, 0, 5 and negative 6, negative 5, negative 5, negative 8, negative 8. So first question we need to answer, if this relation is represent function. To represent function, we have to have in this coordinate only shortly saying x cannot duplicate. Okay, so which means every the x cannot have two y's. It's not happening. You cannot do that. And which means in this coordinate x cannot repeat. If x is repeating, that means it has two different y's. So let's see what we have. Negative 6, 5, negative 5, negative 8. So it doesn't, there is no repetition of x's. That means, excuse me, this relation is a function. Next, B. What is the domain? So every single x, the value of x is a domain. In this case, it's going to be negative 6, 5, negative 5, negative 8. I picked up all x's. And first number always x, second number is always y. So it's nailed it. That's how we know that it's x and how we know that it's y. Because in first position always x. C, what is the range? Range is always y, the value of y. So it is going to be 0, negative 6. Let me highlight them here. 0, negative 6, negative 5, negative 8. That's a range. So negative 6, negative 5, negative 8. That is a range. Range, this is domain. Okay. Question number 2. We have another set of coordinates that is negative 2 and 4, negative 7 and 2, 1 and 1, and 2 and 2. Well, let's check. Is this coordinate, is this function or not? So let's see. Our x is negative 2, negative 7, 1, and 2. There is no repetition. So that means it is a function. And the domain is going to be all these underlined with green colors. Negative 2, negative 7, 1, and positive 2. And then range. Range is the value of y. So let me see. This is range. This is range. Second number. Second number in coordinate. That's your range. So range is going to be 4, 2, 1, and 2. Okay. Question number 3. So evaluating function, so we have f of x is equal 7x plus 8. And we need to evaluate a, f of negative 3, b, f of x plus 1, and c, f of negative x. Okay, let's do it. So f of a, let's do case a, f of negative 3 is equal 7x plus 8. So instead of x, we are plugging 3. So it is equal 7 times 3 plus 8, which negative 3, excuse me. Seven times negative 3. So that's going to be equal, f of negative 3 is equal negative 21 plus 8, and f of negative 3 is equal negative 13. Okay, b, let me change the color. So b, we have f of x plus 1, which is going to be 7 times, instead of x, we are plugging x plus 1 and plus 8. So once we distribute, we are getting 7 equals 7x plus 7 plus 8, like terms. And we are getting 7x plus 15. So f of x plus 1 is equal 7x plus 15. And the third one, c, let me replace with orange color, carrot, the color of carrot. So c, f of negative x, all we're going to do, plug negative x instead of positive x. And that is going to be 7 times negative x plus 8. So f of negative x is equal negative 7x plus 8. Okay, moving to question number 4. So we have f of x is equal x squared plus 6x minus 5 minus 6. So we need to find a is equal f of 9, b f of x plus 1, and c f of negative x. Okay, let's plug. So f of 9 is equal 9 squared, instead of x I'm plugging 9, 9 squared plus 6 times 9 minus 6. So 9 squared is 81 plus 6 times 9 is 54 and minus 6. So 81 plus 54, it's going to be 135 minus 6, it is going to be 129. So f of 9 and f of negative x. Okay, let me okay, that's blue one. So now let me change to a green one. Let me take dark green. There we go. So this was A. Now we are doing B. F of x plus 1. That is equal x plus 1 squared plus 6 times x plus 1 and minus 6. So there are two ways, x plus 1 squared. You either can break down as x plus 1, x plus 1. That's not the best way. but you still can break down like that and multiply. I would rather use a better way, x plus 1 squared. It's a formula like a plus b squared. A plus b squared. And a plus b squared is equal a squared plus 2ab and plus b squared. Remember? So let me write down f of x plus 1 is equal. So instead of a, we plug x. So it's going to be x squared. Instead of 2ab, it's going to 2 times x, and b is 1, right? Times 1. And then plus b squared, which is going to be 1 squared, plus 6 times x, 6 times 1, and minus 6. Plus 6 minus 6 is gone, and we are getting x plus 1 is equal x squared. So what do we have? Plus 2x. So 1 squared is 1. Negative 1 plus 1 is gone. Plus 2x plus 6x, which means we get x squared plus 8x. Oh, I'm sorry, this is multiplication. I thought it's subtraction. My apologies. Let me clean it. Which means this one is surviving and coming out plus 1. Okay. And f of negative x, yellow color. Let me see if I can use 1 second. There we go, thicker so we can see f of negative x. F of negative x, this is c, is equal, so x squared, so it's going to be negative x squared plus 6 times negative x and minus 6. Okay, so f of negative x is equal x squared minus 6x minus 6. And that's it. Okay. Question number 4. No, this is number... Which question is number 3? Yes. Number 4. Let's see what we have. Number 4. Number 4 is similar to number 3. All you have to do, plug numbers. That's it. So you can do... I will write down question number 4. I write down C, number 3, and number 2. Right? Okay. Meanwhile, we are moving to number 5. What do we have? F of r is equal square root r plus 3 plus 4. So a is f of negative 3. So instead of r, we are plugging negative 3. That's going to be negative 3 plus 3. And here is plus 4. So this is 0. And f of negative 3 is equal 4. Next, b. B is f of 46. So which means Instead of r, plugging 46 plus 3 and plus 4. So we are getting 49 plus 4. And this is equal. Square root of 49 is 7. And plus 4, and we are getting 11. And lastly, C. What do we have for C? F of x minus 3. So we are getting square root. Instead of r, we are plugging x minus 3. And then plus 3. And plus 4. Right? So what's happening? Plus 3 minus 3 is gone, and we are getting square root of x plus 4. All right. Okay. Moving to question number 6. Number 5. Question number 6. So we need to evaluate the function at the given value. Okay, so we're doing same thing. It's just more for rational expressions. So f of x is equal 7x squared minus 1 divided by x squared. And we need to find f of 5. Let's do first thing, f of 5, which is going to be equal 7 times 5 squared minus 1 and divided by 5 squared. This is equal 5 squared. First we are squaring and then multiplication. Remember, order of operation. 5 squared is 25. And 25 times 7, 35, 14 and 3, 17. 175 minus 1. And we divide by 5 squared is 25. So 174 over 25. Number B. B, f of negative 5. So it's going to be, since we have x squared and we know positive number, negative number, we square, we get positive anyway. So answer is going to be the same. Let's try. 7 times negative 5 squared minus 1. And here is negative 5 squared. So which means is equal 7 times 25. Here is 25, here is minus 1. And that is going to be equal, again, 174 over 25. And lastly, C. We need to find f of negative x. So it's going to be equal to f of x because, again, x to power 2, it's going to be same positive x squared. Well, let's see. 7 times negative x squared minus 1. Here is negative x squared, which means f of negative x is equal 7x squared minus 1 divided by x squared. Question number 7. Okay, we need to test the graph is function or not based on vertical line. Question number 7. Here it is. Based on vertical line, let me take orange color. Okay, This is vertical line. Vertical line test says if the vertical line is crossing only in one point, the graph, then we have function. Then y is a function of x. In this case, let's say if I would have this type of graph, then look here, it would cross in one, more than one can be made. As long as it's more than one, that's mean it's not a function. Okay? This one is function. Number 8. Now we need to test vertical line on the graph. This type of graph. Let's say this is 4 and the graph is y is equal 4, for example. So based on the vertical line, we are going to test it. Okay, let's test it again. Providing line and it's crossing only in one spot. So it is function. Yes? So y is function of x. Y is function of x. Number 9. What do we have with number 9? Let's see. Find the slope of the line passing through the pair of process. Okay, we need to find slope. We have 9 and 2 and negative 9 and 2. Okay, this is going to be equal. So the slope is going to be equal. Slope is equal y2 minus y1, x2 minus x1. And this is equal this is our x1 y1, x2 y2. Okay, y2 is 2, y1 is 2, x2 is negative 9, and x1 is 9. So what we are going to get here, 2 over negative 18, which is equal 0. So the slope is 0. And the second part, this is part A, and the part B would indicate whether the line through the point rises, falls, or horizontal. Okay, every time, then when slope is equal 0, then the graph is horizontal line. Every time the slope is equal infinity, the graph is vertical. Every time the slope is some positive number, let's say a, graph goes up. And every time m is equal some negative number, graph is going down, negative slope. Okay, so in this case it's m is 0, which means we have horizontal line. Number 10. So we need to find the slope, negative 6, 5, and negative 5 and 4. Okay, slope is equal x1, y1, x2, y2. So slope m is equal y2 minus y1, x2 minus x1. And from here, slope is equal y2 is 4 minus y1 is 5, x2 is negative 5 minus x1 minus x1 is negative 5, 6 minus negative 6, and we are getting negative 1 here, and 5 plus 6 we are getting negative 5 plus 6, and we are getting positive negative 5 plus 6, positive 1. Hold on. Oh, it's supposed to be negative 6. 1 second. It's more interesting, negative 6. I'll tell you why. So, which means it's going to be here negative 6 minus negative 6. And we are getting 1 over negative 6 plus 6. Getting 1 over 0, which is equal infinity. Every time you divide by 0, you get infinity, which is, we call it undefined. And the slope is undefined. You know, when it's undefined, when rocket is taking off to the space. That's why the slope is infinity. It's straight line to the space. Okay, and the line is vertical, obviously. Number 11.